On today's episode, we have a fantastic guest joining. So welcome Dave to our learning series. Dave McComb is the author of the best-selling book called Software Wasteland and the president and co-founder of Semantic Arts, a consulting firm that helps organizations uncover the meaning of data from their information systems. For 20 years, Semantic Arts has been helping firms of all sizes and in their endeavors, including organizations like Procter & Gamble, Goldman Sachs, just to name a few. Before I do hand it over to Dave for him to tell us a little bit more about himself, I did want to mention that we do have a giveaway on today's session. We will be giving away a copy of Dave's book called The Data-Centric Revolution at the end of this session. We will be choosing somebody randomly, so be sure to stick around till the end. Not to worry, if you are not our lucky winner today, we will also be sharing a discount code so that you can grab a copy of your own. Perfect. And I'm going to hand it over to you, Dave, now to introduce yourself. Just one quick thing before we do get started. If you do have questions, please feel free to put them in the chat. I will be monitoring the chat throughout our session, and we will be sure to get to those questions in the session today. So over to you, Dave.
Great. Well, I'll just keep this short. We started Semantic Arts 20 years ago. We were helping people with semantic technology and knowledge graphs, which 20 years ago pretty much nobody wanted, but we were perfecting our craft, and we eventually discovered more than design, people needed help hand-holding getting this stuff implemented. So for about the last 5 years, we've just focused on what we call becoming data-centric, which is helping clients adopt and change this mindset and get their data moved over into graphs where it's flexible and accessible into platforms like Cinchy. So that's probably a good enough of an intro. So I think people have secretly wanted something like data-centricity for a long, long time. In the earliest days, they didn't think about it because they just had a payroll system and an inventory system. It didn't occur that there was a problem. But somewhere around the 90s, people started thinking, well, we've created a mess. We've got a lot of silos. We need an enterprise data model to bring it all together. But what they discovered was that what they were doing at the time was just a sum of all the data models they had. These things were gigantic, tens of thousands of tables, occasionally more than that, totally unworkable. And it also mostly dropped out of favor because people were implementing packages and nobody was paying attention to the enterprise data model anyway. So right around the year 2001, actually when we started our firm, Tim Berners-Lee also proposed the semantic web as a way of unifying and describing all data across the web. It was and still is a great vision, although it's taken quite a while for people to pick up the implication of that. And so as we came forward.
And actually, Dave, just one quick question.
Yeah.
What was the original trigger in your mind where you where it just clicked, where data-centricity, data-centric as a concept really just entered your mind?
Yeah.
What caused you to create Semantic Arts? Was it the introduction of the semantic web, or was it something else prior to that?
No, it was prior, because in fact we started the firm before the seminal article came out.
Right.
Well, we were staring at the models that people were creating in enterprises and asking ourselves, why are they so varied? Why are they completely arbitrarily different? Two data modelers would design the same system and it would look completely different. And we thought surely there must be some principled thing behind this that would lead you to come together. And there was some very early stuff actually in the late 80s called semantic data networks. And we adopted that. We had a .com in the 90s and took that and applied it to applications themselves and said, what would be a semantic model of an application, which was some very early model-driven development stuff. Unfortunately, that .com blew up on the launch pad in the year 2000, which is why we were out of a job and had no technology, so we started a consulting firm.
I see.
That was the genesis.
Okay.
Tim Berners-Lee's the seminal work or the article in the Scientific American came out in 2001. So we were already pushing this for about a year when that came out.
Right.
And then kind of move it forward. In that intervening period, we were designing things for people, but they weren't picking them up. And we finally realized we were going to have to help people handhold and take them through the journey. And it's right around there that we figured out and kind of coalesced around this idea of the data-centric. We have a website out there called the Data-Centric Manifesto for people to sign on and say, we believe. It's also when I started writing these books, and we kind of changed the nature of our practice. This kind of brings us up to today. Our observation is probably, just going from firm to firm, maybe 1/2 or 1% of all firms, large firms, are on this journey, and almost nobody has arrived at the end game. But it's pretty obvious to us the benefits, the inevitability. Yes, it's going to take a while, but God, it took us 40 or 50 years to create this mess. It's going to take a decade or so to clean it up. And then what does the future hold? We think that the end game for all of this is the end of monoliths. People lament the fact that they have silos. They lament the fact that they've got these giant monolithic systems that cost hundreds of millions of dollars to replace. I think what we're going to see in the end game is pretty much model driven, 90% of enterprise functionality, and the end of monolithic applications. So that's kind of our view of the past and future of data centricity.
Right. And Dave, I know, so I've read your books, and as soon as I read the second one is pretty much right when I reached out to you, and we just needed to chat. But if anyone who's on the session today hasn't read it, highly recommend it. But I wanted to just share a story with the audience around the kind of impact, Dave, that your thinking in the space is having on people. And I'm just going to use one example of someone inside of the Cinchy team who attended a training course that you were holding just a few weeks back. So his name is Mitesh. He did join a past episode, if anyone watched the episode that he joined in our season 1. But just yesterday, he published an article on Cinchy TV. So if you go to Cinchy TV, you can see it's here. The sun revolves around the earth is the article. But really, I'm not going to read it if people can check it out. But one of the analogies that you gave kind of in the opening of that really stuck with him. Now, he obviously already knows about data-centricity. He works at Cinchy after all. He's read your book, but this analogy really just resonated with him, is the fact that in the past, for centuries, civilizations believed that the sun revolved around the earth, and upon the eventual realization that in fact that is not true, it's actually the other way around, how that just changes everything. And I think what I've seen in whether it's our customers or other thought leaders in the space is that there's an aha moment that people have that similar realization that data revolved around the code, but in fact the code needs to revolve around the data. The data needs to be the center of that, hence the data centricity. And if you really understand and grasp that, even at a conceptual level, then the rest kind of just falls into place, which is how silos will kind of fall off the bone at that point, because by separating it, where data is the central source of gravity that everything orbits around, it just changes everything. So that moment may be different for everyone, but I just wanted to share that with you because I know you've used that analogy before, and it was high impact. So,
yep, great, yeah, thank you.
So, Dave, I've heard you say this expression, think big, start small, many times before.
Right.
So can you explain what that actually means?
Yeah, this is kind of a hard fought lesson. We actually started on the enterprise ontology side. So once we had semantics, we believed this was a way to do enterprise data modeling. You could do it much more precisely and simpler at the same time. And we thought once we did it, everyone would see the obvious benefit and just adopt it. But what we discovered was they didn't. We would design these enterprise ontologies. We would design an architecture to consume it, and it was shelfware, which was very frustrating. And then meanwhile, in parallel, we saw people doing agile projects, even agile projects using Graph, but they were just creating semantic silos. So that's not good either. What you need to do, these two things in concert. You need to do enough of the think big part that as you do an individual project, it fits in and it's future proof and will continue to fit in with every other incremental initiative. So this is pretty central to what we do.
Right. So I know you're going to share with us two stories. I'm excited to dig in. So let's start with the first one.
Yep. And both of these fit that theme of think big, start small. There's an investment bank, one of the largest ones in the world. They're also a commercial bank, wealth management. They 50,000 employees, and they had gotten involved in a lawsuit where they were sued. They were contempt of court because essentially clumsy retention records management. So they're very motivated to solve that and not have that happen again. And they had a great. There's several things they were doing excellently. They were able to scoop up all retention related regulations from around the world, simplify it down to policy. They had this classification system. They had solved their email and chat problems, but they still had nearly 100,000 repositories, databases, SharePoint sites, shared folders, documents, stuff everywhere of unknown classification. And so it was still Achilles heel for them. So our sponsor had this intuitive leap that if we could suck up all the contextual information around these repositories, that we could classify them properly and get the bank out of trouble. And so, we did our think big thing. We did an enterprise ontology of most of the back end of the bank. We weren't exposed to the front end part, and then took everything that was even slightly associated with these repositories. So, who put it in there? Who contributed to it? What part of the organization were they in? Where did they charge? What cost center did they charge to? All that kind of stuff. Even where was it in a directory path structure? Took all that information and put it in a knowledge graph that was based on the enterprise ontology, and then expanded out a lot of the very cryptic acronyms, because a lot of the stuff is very brief acronyms that only make sense in a given division, and then just ran a pretty simplistic NLP program over the whole thing, and the result was that we could classify about 25% of all the repositories. And that may not sound like a lot, but in the previous several years, they had classified something like 0.5%. The manual approach wasn't cutting it, and this was enough. It convinced them they're onto something. They launched a much bigger initiative, machine learning, a more sophisticated NLP that continues on to this day. There's a wizard and things like that. But meanwhile, we were able to take that learning and go into operational risk, compliance, technology, and several different divisions of the bank. What we're discovering, that little triangle that I had there, you just have another one. What you have to extend is relatively small. People continue to be surprised at how small of an extension you need to cover yet another functional area, and each one of these subsumes like a dozen more systems. So it's really that part's pretty exciting. The other thing that one of the great lessons learned, and again, this was the client initiating this, not us, was rather than establishing data governance or top-down control over this, because they were worried that this kind of movement would get quashed by top-down governments. They built an internal consortium, and the consortium works kind of like a standards organization where the various divisions come together and just discuss how are we going to evolve this ontology, or the core model, as they call it. So that's pretty much that story. We might want to.
Yeah, Dave, on this, was this using a commercially available or freely available kind of standard ontology, or is it one that was built from the ground up, and how complex was that?
Yeah, well, those are good. Let's start with the complex. There's about, I think, 300 classes and 200 properties in the core ontology.
Okay.
We went out and looked, every time we do another project, we look, is there something available? Is there open standards? And not much in the world in what's called information management, which is the legal department's view of information, things like retention, e-discovery, etc.
Mm-hmm.
And then as we got into risk, each of those, there wasn't a lot that was commercially available. We started from our own ontology called GIST, and extended that. So
okay, cool.
Yeah, I think that was it.
All right, so the moving on to the story 2.
Yeah. So this is Schneider Electric. Schneider is a huge company, something like 180,000 employees in 140 countries, and they make electrical devices. They make, if you have a square D circuit breaker in your house, that's part of Schneider, but a lot of what they do is extreme high voltage, industrial power plants, electric trains, things like that. And their motivation, they wanted to streamline configuration management, because what they were doing, every time they'd invent some new parts, each country would decide, are we going to sell those parts, or when are we going to bring them, and how are we going to price them? It was a very country by country decision. And what would happen, because configuration management was in SAP, which is this giant ERP system, they would pick up the new set of parts, give them to their engineers, who would pour through these gigantic spreadsheets, thousands and thousands of lines, and work out, electrically and mechanically, which parts could be configured with which other parts in these complex configurations. And then there was rules that would turn these spreadsheets into SAP configuration management rules, and etc. So anyhow, that's where they were. They had the insight or the thought that perhaps moving to something more flexible, like a graph database and semantics, would help them. So we came in. Luckily they had all their data in a single product catalog. It was sort of medium complexity, I would call it. It was like 700 tables and about 7,000 attributes. So everything that was known about these products, not only their electrical capacity and physical characteristics and what standards they apply, they conform to, but also what was the price in Austria or Greece or Spain or whatever, if it was being offered there. So again, we did their think big, start small thing, designed enough of the enterprise ontology to cover both their parts and how that fit into their organization, everything else like that, and used an open standard called R2RML to take the relational data, move it into the knowledge graph. And then our original idea was that we were going to use, there's a semantic web standard called RIF, rule interchange format. We're going to use that for writing configuration rules. Unfortunately, this is one of the lessons learned. We brought in a partner who wanted to literally convert what they were doing with their spreadsheets into these rules, and hopefully that was going to translate into the SAP configuration stuff. Turns out that didn't work. But luckily, what did work, what we eventually found out. We went and looked at what did we have in this database, in the knowledge graph. And at one point, toward the end of the first part of the project, we just ran a query and said, you know, how much of this data have we populated? And what we found was that there's only 46 classes and 36 properties in this graph that contained all the data for all million of their products. And at first we thought, you know, does that cover everything? But sure enough, we were working with another partner who was building out a new version of their website, and all the data was there, and all the fidelity was there. So kind of interesting how you go from 7,700 concepts, if you take the number of tables and the number of columns, to what was 82 concepts. So almost 100 to 1 reduction in complexity. And it was actually
sorry to interrupt there. That sounds insane. What was the rest of the data? What was it?
Yeah, you know, we only partially understood, because we came to this realization very late in the project, and I asked the guy who got all the data out, what was all the stuff you didn't take? And he said, oh, a lot of it was blank, and a lot of it was obviously experiments that somebody had done years ago, and there's a lot of redundancy.
Right.
We never actually figured out 100% of what that was, but since then we built a taxonomy of redundancy, I guess. So the next time we do this, I'm going to have the guys carefully go through and say, every column you didn't take, tell me why you didn't take it.
Right.
I want to eventually, because I think people sort of don't believe it. In this case, it's kind of obvious because you could see all the parts and all that kind of stuff. But then, just to put the cap on the project, once we saw how simple it was, we said, wait a minute, let's rethink compatibility and configuration management. I went and talked to design engineers and said, you know, what is it that makes electrical products fundamentally compatible or not compatible? And, you know, they just rattle it all up. There's some obvious stuff, you know, voltage and current and things like that. There's some pretty non-obvious stuff, like whether it fits on the same rail, and does it have the same pin configuration, and is there heat dissipation, and is there's some torque in these little things you flip. But it turns out there's only a few dozen rules you need to know whether two electrical products are intrinsically compatible or not. And so we just implemented those in Sparkle, as it turns out, and ended up solving a problem that, you know, 6 months previous was way too hard to solve. All of a sudden, when you simplify the data, the rest of the problem gets simpler as well.
Right. This just reminds me of the idea that there's not as much data in the world as people may think. So if you get 100 to 1 compression in terms of the structure, and if that were extensible outside of the context of this one organization, which I personally do see that being the case, just imagine what that does to the simplification. For me, that's what gets me excited about the idea of data centricity, is the ability to truly simplify because it's all fake noise. It's noise. It's fake complexity. It's
yeah. I mean, I think a lot of this explosion in data, a lot of it's copies, and some of it is legitimate data, but we don't have to centralize it. You know, the Internet of Things, 99% of that data can stay at the edges. We don't need to know the exact temperature of that compressor every millisecond, especially when it doesn't change, you know?
Right. Yep. And I see someone just made a comment that it's important to say that data-driven is not data-centric, which
right.
I know you've said that many times, and I totally see that as well. Anyone who's seen any past episodes knows that that's kind of a central theme. But are you finding that people are actually waking up to this realization? Because there's, and I know just in my experience, there's so much confusion in the world of data. But are you finding that the movement is truly starting to take hold, where there's a growing amount of people in large corporations that actually understand the difference between being data-centric and being data-driven?
It's getting there. And there's nothing wrong with data-driven. In fact, data-driven is a good idea, that, you know, you should base your decisions on data rather than opinion or heuristics or whatever. But just saying that doesn't mean it's data centric. You could have silos of data drivenness, and a lot of people do. So some people are realizing that, but it's change is slow. It's surprising how slow it is.
Yeah. So for if anyone is looking for more information on these stories, I know, Dave, you have case studies published on your website, so people can check that out. The links are here. And again, this video will be available on demand after. So if you don't want to take notes now, you can always access it. It'll be published later today. So maybe just, Dave, of those stories, what would you say are the key lessons, the key points that people need to take into account as they're going about their own organizational transformations away from app centricity towards data centricity?
Right. Well, one, if I remember these slides correctly, was that, think big, start small does seem to work, both giving you a platform to migrate to and giving you something that sponsors and stakeholders can see right away. In fact, probably the most important part of start small is when you describe this, what we're talking about, it's too abstract for most people. Most people won't see it until they see their own data linked together in a way they hadn't seen it before. So that's one key takeaway. Complexity is what it gets you every time you turn around. Like we said with the product catalog, it was the complexity of the data that kept you from seeing, what was essentially true there. And what was my third one there? Oh yeah, we didn't mention this much, but it's hugely powerful. Every one of the nodes in these semantic graphs has a global identifier. They look like a URL, it's really a URI. But what that means is once every single node is completely unique in the globe, you don't need any metadata to join things. They just join themselves. It has the exact same identifier, it snaps together. It doesn't care what column or table or anything it came from. It just snaps together. So yeah, those are three big takeaways.
Okay, great. And I know you had a reference here. Right. If anyone is looking for more information to check this out, an article on your site.
Yeah, very approachable.
Cool.
So since we only have just a minute to go, I'll just quickly give you an idea of what's coming up next week. So next week, joining Cinchy and Catalyst Earth to uncover how data centricity is being used to disrupt the geoimaging industry by unlocking access to data. It's going to be a great session, so be sure to join us next week for some more real-life transformations from app centricity and uncovering the benefits that come along with data centricity.